Hello YouTube, this is OJ Cubing, and today we're going to be learning the beginner's method for solving a Square-1. So Square-1 can be quite a daunting puzzle at first, especially because it looks and pretty much turns unlike any other cube, and it shape shifts and stuff, and the notation is really weird for it as well, and it's kind of annoying when you get started off with it, but once you get used to it, it actually becomes quite fluid, and it's quite a fun puzzle to solve, in my opinion. So first of all, let's go back to the very basics. You have to hold it like this, where you have the shorter bar on the left and the bigger bar on the right. You can hold it this way round or this way round, just not holding it this way round. So if we hold it like this, we see that we can turn the up face and the down face, and then this here is called the slash face, and you can turn it like that. And you can only turn it if you've got a straight line going along here and a straight line going along there. Otherwise, if we try and did a move like this, it would of course bandage. And if we had a move like this, for example, as you see, there's an edge in the way there and we can't turn it like that. And so it bandages. So anyway, let's get into the move notation. So Square-1 algorithms are written as coordinates. So that'll be in open brackets, a number, comma, another number, and then close brackets. So within the first number we have there is related to the up face, and positive numbers means it goes clockwise like this, negative numbers means it goes anti-clockwise like this, and same with the down face. If we it's the second part of the coordinate, and positive numbers mean clockwise like a normal D move, and anti-clockwise numbers are negative like a D prime. So the coordinates are based off how sort of far around the cube we are turning. So each of these little pieces is worth 1, and each of these bigger pieces are worth a value of 2. So as you can see, we've got 1 and then another 2 here, a 1 there, and etc. So if we had the coordinate 1, 3, we would have to turn the up face by 1, which is this little one here, and then the down face by 3. Now you see, because it's positive 3, we go clockwise around it, and then this counts as 2, so we count 1, 2, and then this one is the third, so we go 1, 2, 3. So a 3 move is a quarter turn like this, and it goes 1, 2, 3, and that would be our coordinate. After every coordinate in between each coordinate, we have a slash move, which means turn it like this. And then, for example, if we had the move 6, 0, we'd have to turn this by 6. And then a slash maybe, and then if it said maybe 0 minus 3, we would have on the top face not move at all because it's a 0. On the bottom face it would be minus 1, minus 2, minus 3, and so we go from here down to here and then a slash, and you get the gist. And that is how the algorithms work. So let's check out a few basic algorithms. Okay, so the first basic algorithm you need to know is the face flipping algorithm. And this basically means we take the top face and the bottom face and we flip them around, so we have the yellow face here and the white face here in this example. And that algorithm is very simply slash 6 6 slash. And then I guess we could have minus 1, 1. As you can see, that's put yellow on top, and these are flipped on these bars, but we're still holding this on the left-hand side, the shorter bar, and so we have yellow on top and white on the bottom. Or a simplified version of that I sometimes use is slash, and then sort of an M2 move, and then a left slash like that, and then readjust that. But that's just sort of a way to get around it easier without having to 6 and 6. Within the slash. The other sort of algorithm we're going to need to know is slash 6 0 slash 6 0 slash, and what that does, as you can see, is it flips around this bar, and because we're moving it to and from this position, that position, this position, that position, you'll notice that we might end up at the end with a bar like this, and that, as I said, was solved by slash 6 0 slash 6 0 slash. And so that will help out with this bar parity, but for the most part we want to ignore it whenever we can and just keep solving the Square-1 whatever this is and only fix that at the end. And so let's put this back into the normal shape. 6 6 slash minus 1 1. Okay, and so that is basically the move notation and the few basic algorithms that you'll need to know for sort of flipping stuff around. So let's go and scramble up our Square-1 then. Okay, we have got it scrambled now. I always use a scrambler algorithm or an app to scramble the Square-1 because of the bandaging. It gets quite difficult to scramble it normally, and so I find that using an app really helps it. As you can see, we've got quite a daunting shape here, and obviously we need to make it back into a cube shape first. Now the way we do that, and this is called the 8 edges method, and that's because we need to get 8 edges onto the top face in the right order. And so it doesn't matter about orientation as of yet, but what we want to do is want to create these little pairs of 2 edges with each other. And if you haven't got any of them, that's quite easy to do. For example, if we place this over here, see that this is down there, we know that when we move that down, it's going to create a pair over there. And things like that, if they're on their own, they're quite easy to pair up if you haven't got any to start off with. But likelihood is you do. Now what we want to do is we want to put all the edges on top. And so what I'm going to do is I'm going to move this over here so that I know that wherever I bring up is going to come into this place here. And I can put this edge pair down here, for example. And then when I move that up, it will join up with the others to make a 4 edge pair. We want to make that into a 6, and I can see we've got this one over here. So what I'm going to do is I'm going to put it into the bottom face. I'm going to try and turn it so that it will go upwards. But as you can see, we can't quite do that because we've got this big edge in the way here. So what I'm going to do is I'm going to place it at the top, and I see that I can move it like that. So I need to place this so that it's ready to receive at that top end. And then when I move this up, it will make this big semicircle sort of full of edges. And that was where I want to get for now. I'll just explain a couple of cases of that before we move to getting all 8 edges. You need to first of all create this semicircle with 6 edges. One of the difficult things you might have to face, so you've already paired up 4 of them, and you've got it in this sort of fashion here. Now as you can see, if we want to try and get this edge pair up to the top without breaking it like that, then we would either have to turn it so that we can turn it up at the bottom there. As you can see, this edge is in the way. Or if we try to go at the top there, this edge is in the way. And that's very unhelpful. And so what we're going to have to do, the only face this will turn without breaking up this pair is going to be like this. So we can put it up into the wrong space. But then if we move it to the side so that it's in the top, do the slash again, and then move this so that it's ready to receive that at the top, do the slash again, then we've got that edge up there. And then we've got the 6 edges. I know I haven't really done that in terms of algorithms, but that should be just sort of you messing around with the cube and trying to figure out how to get all your 6 edges on top. And so now we have the last 2 edges. There are 3 different formats it can be in. One of them is paired up like this one here is, and that's easy just to go up. If we've got it in this case, it's also very easy. This is when we've got it sort of at, if we turn it like this, we've got it at 12 o'clock and 5 o'clock. And that means we can just line these up like this and slot it up there. And then we've got our 8 edges. And this is the tulip pattern we need, by the way, guys. And so you should always be trying to aim to get this tulip pattern. And we can then use an algorithm to get that to a cube shape. But quite often we will have it in the third case, and that is when they're sort of at 12 o'clock and 3 o'clock or at 90 degrees to each other. And this is going to take a little bit of an algorithm. And I like to think of it as not an algorithm because you can figure out intuitively, but I'm going to tell you the algorithm. So if we start off with all of these 6 tulip edges on the left of this slash, and then this is at 12 o'clock and 3 o'clock, we're going to do 2, 0, slash, minus 3, 4, slash, 2, 0, slash. Now, the way I like to think of that is we want to first of all displace a pair with this edge here. So we're going to place that edge over here and we're going to displace it with this one. We can then see that if we turn it like this, we've got this L shape that we can easily insert upwards afterwards. So what we need to do is we need to place our pair of edges down in this corner here, which can easily be done by moving it like that. so that when we move that up, it will parrot the 6 edges again, and we've got this line sort of shape that we can quite easily move up to there like that. So anyway, that should be most of the cases of how to make a tulip, and hopefully you'll be able to understand that. If not, just keep practicing around with it and you should hopefully get there fairly soon. But once we got into this tulip, we need to make sure that the slash is going directly through the middle of it, and we're going to do the algorithm slash -2 -4 slash -1 -2 slash -3 -3 slash. Now that's quite a difficult algorithm to remember, but you're just going to have to stick with it. And as you can see, we've now got the cube shape, and we can move on to orientation of both layers. We're going to start off with corner orientation. So as you can see in this case, I've got the 3 corners up the top here, 3 white corners. I got white on top, by the way, and then I've got 1 corner down here. So every move we do in the cubic form, we have to make sure it's offset by a coordinate of 1, because that means that when we do all these turns, it's going to keep it in its cube shape. If we have it like that, as you can see, it's still off by 1. If we had it like that, it's off by 2 on if you add both layers, which means that it's going to start disforming the cube shape. So if we had it like that, it's off by 1 on the down face, and again, we can keep it as the cube. So what you want to do is you want to, if this is in the bottom corner, if we want to keep these 2 corners together, then we need to place that in the bottom left corner. So when we do our slash, we're going to pair these 2 up, and we can then move that up next to these on the top layer. So again, we need to make sure 1 layer is offset by a degree of 1, and then we can do that slash move to move it up to the top, and then we have 4 corners orientated, and all 4 of these will be orientated as well. One of the slightly different cases you might have is if we have 2 diagonals like this. So what we need to do is just ignore 2 of them for now, and we want to pair up 2 of the others. So let's say we want to pair up this one with this one down here. So as you can see, when we pair that up like that, it's actually going to pair up the other 2 as well. And then we can then move around the cube and offset it again so that we can have all 4 of them on the top. That should be pretty intuitive, and we're going to move on to edge orientation now. Edge orientation, you can reduce the number of edges you have to do, but I will be telling you how to do that in an advanced tutorial, which I will release on Monday or Tuesday or Friday, whenever it comes out. I don't really know. But yeah, check out for the advanced tutorial once I've done this. It's basically just going to be an add-on to the beginners. So let's keep going with edge orientation. So the edge orientation algorithm we're going to be learning is one that swaps this edge up here in the top right with this one in the bottom right. So you can see they're opposite each other, and it will swap these 2 here and here. So what we need to do is we need to make sure we've got a yellow here and a white down here. The algorithm we're going to be learning is 1 0 slash 0 -3 slash 0 -3 slash -1 -1 slash 1 4 slash 0 3 slash. And so that has got us to 2 edges unorientated now, and we can again position that here and position 1 here and do that algorithm again. Now all the algorithms will be in the description if you want to look at them again, and hopefully I've got them on screen as well. But I'm going to explain to you this, how I remember it this time. So first of all, we need to offset our cube, so we're going to move it like that and do our slash move. We then have 2 D prime moves, as I like to think of them. So a full 90-degree turn there, slash, a full 90-degree turn there, slash. And then we need to swap which layers are offset by 1. So we're going to move that one, and then slash again. We then need to offset this one again, offset this one, but then move it around by another D move. So that makes 4 in total, slash. And then another D move, which should align these up and orientate all the corners again. And so that is how I remember it. And then if we do the last one, I can show you it at speed. And then we have orientated both of our layers, and we can move on to corner permutation. So for the beginner's method, we're going to be learning how to only orientate the top layer, as in corners only. In my advanced tutorial, I'll teach you only a few more algorithms that I think are quite simple to learn that will orientate the corners of both layers, and that will make it quite a lot easier. But for now, we're going to learn how to do it just one layer at a time. So there are two types of swap. There is the adjacent swap, which you'll notice by having headlights like this, and the rest of them aren't solved. So we put the headlights at the back, and then we do the algorithm slash 3, -3, slash -3, 0, slash 0, 3, slash 0, -3, slash 0, 3, slash. And as you can see, that has permutated all of our corners on this face up here. So now we need to work on the bottom face. And to do that, we can do our face swapping algorithm from earlier. So it's slash 6, 6, slash, that's 1, 1. And then as you can see, we've got the yellow face on top. Now here we do not have any headlights, and that's because we have a diagonal corner swap. And for that, the algorithm is going to be slash 3, 3, slash 3, 0, and we do that 3 times. So slash 3, 3, slash 3, 0, slash 3, 3, slash, and then we don't need 3, 0 at the end because obviously it is correctly done. And so that is the adjacent and the diagonal corner perms, and that will be all you need to learn for corner permutation. And now we're going to move on to edge permutation. Okay, so the algorithm we're going to be learning for this is for swapping 2 of these adjacently and 2 of these adjacently. And we're going to hold it like this and do the algorithm which will swap the back and the right and the back and the right on these two. So as you can see, we hold it like this and then we perform the algorithm. And so if we have a look at this cube here, we can see we've got 1 pair to do here. And on the bottom, we don't have any of those sort of looking things. So what we're going to do is we're going to think intuitively and think what's going to work best. What I might want to do is I might want to put this blue into this blue slot. So we're going to flip these 2 edges here. To position those 2 in the back and the right, and these 2 in the back and the right. And so we do the algorithm that goes as follows. -2, 0, slash 3, 0, slash -1, -1, slash -2, 1, slash. As you can see, that's now solved the top layer, and we have the bottom layer to solve. To make it easier, we're going to do the algorithm to get it onto the top face. And so this is actually a U-perm, as you can see. We've got a 3-edge swap like this. And what we want to do is we want to always swap into the opposite slot. So if this color here is the opposite of what it needs to be, then we always want to try and swap that out of this case. And so here we can swap the red into that case, and that is going to displace that and make it all okay. And so we don't actually worry about the bottom layer for now because it's solved, but we can place these 2 at the back here and do the algorithm again. And then, as you can see, we've just left with an adjacent swap and another adjacent swap. So if we do the algorithm again, then it'll actually solve the entire cube. And I'm just going to show you a few more cases now that might be a little bit trickier. So as you can see here, we've got a sort of awkward case in that what we basically need to do is we need to again displace one of these opposite colors. So I'm going to displace this one. It could be this one as well. And we're going to displace it with the blue. So we're going to do that algorithm and displace those 2 at the back. And then again, we've got the simple U-perm, which we can do with another 2 of those edge flipping algorithms, or swapping, I guess. And another case we might have is an H-perm like this, and this can be not such a nice case because it seems like there's nowhere we can get rid of an opposite color by swapping one into it. So all we have to do is do one of those flipping algorithms straight away, and then we can have a look around the cube, say, I can swap these 2 out, and so we place them in the back and the right, do the swapping algorithm again, and then again we've just got the simple U-perm. Or we might have this case here where we've got a opposite swap, but these 2 are both solved, in which case we can again just do the flipping algorithm wherever we want, and then we're left with a U-perm again, which we can go and solve like this. However, in this case, as you can see, we've got an adjacent swap on the top, and all of this is solved. So if we were to try and do that double swap there, like this, then we've got exactly the same case, but now it's on the bottom, and so maybe we could swap these two over. But now we've got it on the top again. And so basically this is a parity algorithm. And this is one of the most horrible algorithms to learn in the history of cubing, which I admit, and it is very horrible to learn. But my recommendation is just to keep doing it over and over until you eventually get good at it. So anyway, the parity algorithm will swap the front edge and the right edge like this. And the algorithm goes like this. Slash -30 slash 0, 3, slash 0, -3, slash 0, 3, slash 2, 0, slash 0, 2, slash -2, 0, slash 4, 0, slash -2, 0, -2, slash 0, 2, slash -1, 4, slash 0, -3, slash, and then as you can see, all of our edge permutation is correct. What that algorithm does do is it flips over this bar, but again, we can just do that with a simple slash 60, slash 60, slash, and then we can adjust our faces, and then we will be done. You just got to find your own way of remembering it, and eventually you should hopefully be able to execute it and do it without messing up too often. And as you can see, I can do it fairly quickly like this now. So that just comes with practice. You just got to keep doing the algorithm over and over again till you finally understand how to do it. But yeah, guys, that is the end of the beginner's method for the Square-1. Hopefully you're able to solve your Square-1 now. Once you got used to those algorithms and all the move notation, and you got used to how the cube moves and stuff like that, then please come back for the how to improve your times at Square-1, the advanced sort of tutorial. As I said, I'll be teaching you how to be more efficient with your edge orientation. I'll teach you how to do corner permutation for both layers, and I might throw in some more algorithms in there as well, just to make your life a little bit easier. But anyway, guys, that is it from me today. Hope you all enjoyed, and I will see you all in the next one. Bye!